Hello, Dr. M here. We're continuing with addition across alkenes. This time we are adding two X groups across the alkene, and of course that can happen from the top side or the bottom side of the alkene, because I told you in previous videos, whenever you have a double bond, that region there is flat, it's like sitting on your bench, so the reagent can attack from the top of bottom face. But the main rule is that the two halogens, for this case two bromines, are added opposite to each other. Remember, the same can happen for Cl2. If you have a Cl2, is still gonna behave the same way as a Br2. So this is just a similar explanation for Cl2 and Br2. Alright, so what's the mechanism? First, the diatomic molecule will use one of its halogen, which is posing as partially positive, to be attacked by the pi bond of the alkene. So that's the first step. And then that atom is going to use its lone pair to attack the other carbon. And that leads to this guy falling off, the Br falling off as Br minus. You get two possible intermediates depending on the approach. If you're attacking from the top face or bottom face, if you're attacking from the bottom face, you get this intermediate, bromonium intermediate. If you're attacking from the top face, you get this bromonium intermediate. Now, to get this product, the bromide that fell off will attack from the opposite side to the three-membered bromonium ring, because the three-membered bromonium ring brings sterics on that side. In this case, it's from the bottom side, so this has to approach from the top side. So you get a top face attack to pop open the three-membered ring, because three-membered rings are angles, they are ring strained, they are not stable. So attacking from the top face, the Br gets a wedge bond, and the method that's pre-existing will be pushed back, so it gets the hatched or dashed bond. Well, this opens up, the three-membered ring opens up, keeping the stereochemistry on the bromide off the three-membered ring. So it keeps its weight, it keeps its dash bond. To get this product, the bromide will attack from the bottom face, because the bromonium is on the top face. The same concept, we're opening up the ring, donating the lone pair of electrons from the bond to the Br that's positively charged, so now it becomes neutral. So it's gonna keep its wedge, it's gonna keep its stereochemistry, its wedge, but this guy, because it's attacking from the bottom face, will have, that bromine will have a dashed bond, and that means the methyl has to be flashed up. So these two products are enantiomers, and as you can see, we've done anti-addition as per the rule. Right, so now use the same concept. I'm not going to push arrows. Use the same concept to answer this question. Remember, there's no formation of a carbocation, there's no shifts, it's just direct addition but anti. So in this case, this is where the reaction is happening. So one bromine will have a dashed bond, and the other one should have the other one should have a wedge. Simple as that. The hydrogen is there, so if you want to show it, it's fine, but there's no need to show. If you show it, then you have to show it here with opposite wedges. Now you get the other opposite stereochemistry for the other product. Again, if you want, you can show your hydrogen. So those are the two possible products for the question A. For question B, if the bromide attacks that carbon from the back, then the bromide will have a hashed bond on there, and next door you'll have a bromide with the opposite geometry. You'll have a bromine with opposite geometry because it's anti-addition. But it can choose to attack the other way, like the first bromine could attack from the top to make the bromonium intermediate, pushing the ethyl back. So in that case, it has to have a wedge because it attacked from the top, and the other bromine will have a dash because its anti-addition is going to open up the bromonium intermediate from the opposite side. You get the stereomass because one stereocenter is kept constant. Very simple. Now here the substrate stereochemistry is not defined, so we're just going to do the same process. Assume the first bromine atom from Br2 attacks from the top, from the bottom I mean. Assume the first Br from the Br2 attacks from the bottom. Then that means it will have a dashed bond or a hatched bond, and since it's anti-addition and you're adding across the alkene, the other bromine must have opposite bond type, in this case a bold wedge. And then the other answer will just be the opposite of this. If the first bromine atom attacks from the top, flashing the ethyl back, it has to have the large bond, and the other one has to have the opposite geometry. As simple as that. For the next one, you have two alkenes, and in this case, let's first go ahead and assume that we have enough to react for both alkenes, excess. So you're going to end up with mixtures. And this mixture will be like this. So let's start assuming that the first bromine attacks this side from the top face. So the bromine will have to have a wedge here, and the bromine will have to have the opposite bond. Let's do the same on the other side. So the bromine has a wedge here, and the other bromine will have a dashed bond. In this case, we're going to do the opposite. We'll assume the first bromine is attacking from the bottom. We'll assume the bromine is attacking from the bottom, so it will have a dashed bond, and the other bromine will have a wedge onto that carbon. Let's do the same thing this side. First bromine attacking from the bottom face, and the second bromine opens up the bromonium intermediate by attacking from the top face. Now here we're going to do the same thing as we did here, just to make sure you have four conspicuous products, different products, and then this side we're going to do the opposite, because this reaction is happening on different sides of the molecule and it can choose to do what it wants to do. So now let's draw the opposite of these bondings onto this ring. Those are the four products. Which one is the major product? No one knows. You let the experiment decide. But to me, right now, in theory, they should have equal chance of formation. So same concept applying to the next question, E. So let's assume you're adding across here. The first bromine is adding from the bottom face, the other one should add from the top face, and again assume this side from bottom face. We're assuming we have excess, and the other one opens up the intermediate from the top face, and then here, if you flip this molecule, you will get this compound, which is just the opposite of addition sequence of the bromides, making them anti. I think by now you know what to do. You must have even drawn the answer already and thinking like you already got it, so I should move on. And let's see if we could make other two pairs of products like we did in example D. So we're just going to do same bonding to your left, dashed bond and a wedge. Okay. And then here we're doing the opposite, starting with the wedge because this reaction has to go with anti-addition. And then here we're keeping the same way this one is. You just want to make sure you're ending up with completely different products. Now once you do that, you have to check and make sure that they're completely different. For this one, it's only one double bond. Or if you do anti-addition, you're gonna get this product. If you have to be careful with this question, because if you flip it, if you do a rotation around this bond, you'll end up with this compound. And notice that it has internal plane of symmetry. So these two products here are not enantiomers. They are not enantiomers because they have an internal plane of symmetry. But anyway, that's for another topic. The only possible products are these two, either that or this. If you're asked concerning Howard projection, all you need to show is one bromide up and one bromine down. In this molecule we have a CH3. We have a CH3 here. So if the bromine attacks from the top, the CH3 is flushed down. If the bromine attacks from the bottom, the CH3 is flushed up. And once you added your first bromine, you need to know how to place the other one. Should be anti. You just have to follow the anti rule. This hydrogen is simply that hydrogen and that hydrogen, maintaining anti-addition. So that's it about addition of bromines, or addition of diatomic bromide, or the addition of diatomic halide across the double bond. Keep practicing to perfect. Bye.